There we go. We're talking about piecewise functions. Again, this is all about multiple functions doing different things. So if you look at this first example here, they've graphed this for you, okay, where they've got these different aspects and they're plugging them in. When you're between -3 and 1, we graph this guy, okay? At 1, we just graphed the number 2, so that was the solid dot right there in the middle, okay? And then when x was greater than 1, we graphed this parabola. It doesn't look like much of a parabola, but it's all about where things are set up. These are piecewise functions. So if they're a function, it better pass the vertical line test. Does this graph pass the vertical line test? Yeah, because the open circles there, if I drew a straight line right there, I would only touch one open circle. Okay, or one closed circle, sorry. One closed circle. You got to make sure that you're passing the vertical line test, because if you don't pass it, that doesn't do us any good. It's no longer a piecewise function. All right, so we're going to graph some functions in here as well. So a little bit of practice of what you've done the last couple of days if you're not positive yet. So functions are defined using more than one function. That's what a piecewise function is. We're going to graph f of x. If I'm graphing piecewise, I always start off by drawing the lines that everything lives in between. Okay, kind of the parts that we have here. So for example, in this first one, I'm graphing that absolute value equation between -3 and 0. All right, so the first thing I'm going to do is just kind of draw some dashed lines here at -3 and 0. It's nice to have a highlighter for me because they're not really part of my graph, but it helps me to visualize what's happening. Okay, so this equation right here lives between -3 and 0. So right here on my graph, I'm only going to graph that shape. And then when x is greater than 0, I'm graphing this shape. All right, so when x is greater than 0, I'm graphing that shape. And then the only other thing I have left is if x equals 0, I'm graphing 4. That's the easiest one. What does that tell me? If x equals 0, it's 4. What's that going to become? Point. Just a point. It is a dot on my graph at 0, 4. Because when x is 0, my y value is 4. It's just a point. Everybody good with that one so far? All right. So first thing we're going to do is let's just do some like we did in Bellwork. F of -1, f of 0, f of 1. Find those three values real quick. It's just exactly what we did in Bellwork. Take those values, plug them into the correct equation, see what you get. So, Emmy here, if I wanted to graph or find f of -1, which equation are you plugging into?
I plugged it into the first one.
Yep, the first one, because -1 lives between -3 and 0. What did you get when you plugged it in?
-4.
Yep, -4. Okay, we take it right there. -1 plus 1 is 0, -4 gets me -4. Then I'm doing f of 0. Morgan, what's f of 0 going to get you? Which equation did you plug into? Yeah, the middle one. Because if x is 0, all I got is 4. So, x is 0, then my answer is 4. There's not really a lot of thought process to that. And then f of 1, Dahlia, which equation are you plugging into? The last one. What did you get when you plugged into that one? You just get 1. Square root of 1 is 1. Okay, so we got some points. If you wanted to, you could do it this way, where you just plugged in a whole bunch of numbers and plotted some points. Like we know the point -1, -4 is going to be on my graph. All right, we know the point 0, 4 is going to be on my graph. We know the point 1, 1 is going to be on our graph. That's what we found out so far. We've done some ordered pairs. All right, but to graph it, it doesn't make a lot of sense to do it that way. We're going to graph it just like we would normally graph. Okay, using our transformations, it's going to make things a little bit easier. All right, so my first one, absolute value of x plus 1 minus 4. Show me with your arms, what's my shape going to be? It's a V. Avery, which direction is that plus 1 going to take me? Left 1 and the -4. What's the -4 going to do? Good. Left 1, down 4. Oh, that's our starting dot right there. We already had it because that's what we plugged in. But that's the middle of my V. And then I'm making my V shape from there. So I'm going up 1, over 1, up 1, over 1, up 1, over 1. And I only graphed it between the two lines because that's where it lives. Okay, it only lives between -3 and 0. So I only graphed it right there. You could keep making the dots, but you would just erase them anyway. So I don't. So I'm making my V. What's going to happen when I get to -3? Am I actually supposed to make a dot at -3? Yes. It's underlined. That means it's a closed circle on my graph. It is part of my answer. So I'm going to make a closed dot right there. What about at 0? Am I doing open or closed circle? Open. I can't do a closed one. I already have a closed dot right there. but I have an open circle. Why? Because it is not included. It is not underlined right there. Then for the middle equation, I'm graphing 4. All right, I already did that. That was this closed dot right here. And then the last one, I'm graphing square root of x. If I'm graphing square root of x, Reese, what's my shape going to be?
It's going to be the
teapot. Do I get shifted at all here?
No.
No, so what's my pattern?
It's going to be 1 through 5.
Yep, up 1 over 1, up 1 over 3, up 1 over 5. Ran out of space, that's fine. Connect my dots. Something like that. And I'm going to put an open circle there at the start for 2 reasons. One, I have to pass the vertical line test, and if that's a closed circle, it breaks with the closed circle I already have. And the other reason is because it's not underlined. If it's not underlined, it's not part of my answer. Questions on that thing? All right, let's do domain. So if I'm doing domain here, talk with your neighbor. Think about what do you think the domain is. Domain here. Kylie, what do you think on domain? -3. So that means she's starting her x values at -3. I agree with that. And does it go all the way till infinity? Did I skip anything in between? No, I'm good. -3 to infinity. Good. That's our domain. Range is going to be a whole lot harder. Okay. Range is kind of ugly, especially for this one. I start off down here at the bottom. When is the first time I'm going to touch my graph? -4. So I'm going to touch my graph here at -4. Do I actually use -4? Is it a closed circle? Yeah, so I can use -4. From -4 until when? -2 is when it's going to stop going. Okay. From I start down here, -4, and I start going up. Boom, right there at 2, I stop touching anything. Okay, so I can't go from -4 like to infinity or something. It's a break in my graph. There is no points between -2 and 0. Okay, so from -4 to -2, I'm going to throw that in brackets because I actually have a point at -2. What's my next number going to be that I use? 0, bracket or parenthesis on 0. Parenthesis, because I'm not actually using it. It's an open circle. Okay, so I'm starting right here. So I went from -4 to -2. And then from 0 until when do I stop going up? Infinity. This arrow right here, while it's not going up real fast, it is going to keep going up and up and up forever and ever. So we would go from 0 to infinity. It's rough. Okay, that's a rough range, but it's just a matter of thinking my way through what values did I use? Was there a skip in my graph? Was there a jump? If so, make sure you write it accordingly. Is f continuous on its domain? When you think of the word continuous, okay, the simplest way to think of continuous is if something is continuous, you do not pick up your pencil. This is a calculus term. This is a calculus term. So do not pick up your pencil. That's a real not calculus description. That's a really simple description. But the whole idea is not picking up our pencil as we go through it. He's not here. Okay, so for this graph on the domain, using the x values that I used, did I have to pick up my pencil ever to make my graph? Yeah, a whole lot. You cannot trace that without picking up your pencil. So is this thing continuous on its domain? No. Something continuous on the domain would be like a square root graph. Like if I just made a square root graph, did I have to pick up my pencil to make that graph? No. To make an absolute value? No, I'm continuous. I'm continuous. A parabola is continuous. A reciprocal graph isn't because I have to pick up my pencil. And this piecewise function definitely is not because you have to pick up your pencil a lot. Does that make sense with the word continuous? Don't let that be a hard word. It's just, did you pick up your pencil? Okay, let's go to the next one. Number 2, try and graph that without me helping. Try and graph number 2 there, see what you got. So if I'm trying to graph this thing, I'm going to do break lines first. I know I didn't give you a bunch of time. It's a Wednesday, so I'm going to run out of time. If I graph this thing, Allison, where are my break lines going to be? Where is my graph going to be separated? Yep, 0 and 1 are my 2 break lines. which graph, as I look at this thing here, Grace, which graph is going to be graphed to the left of 0? The first one. Yep, this one right here is going to live in this land. Okay, it's going to live over here because x is less than 0. Okay, so if I were to graph that, everybody show me with your arms what's the shape. It's V, but it's negative, so it's really going to be down. There's a 2 in front. What's that 2 going to do? Make us a little skinnier. +1 takes me left 1. The +2 takes me up 2. So I'm left 1, up 2. I'm making a V. I'm down 2 over 1, down 2 over 1, down 2 over 1 because of that vertical stretch in front. There's my V on that side. On the other side, I'm going this way. Open or close circle when I reach that line? Open. So I should have an open circle right there. Then in between there, from 0 to 1. From 0 to 1, I'm graphing x squared. So it's just in between these two numbers, 0 to 1. Show me with your arms. What's x squared look like? Boom, parabola. So I'm going to make a dot there. It's closed because it's got an underline underneath it. So oh no, I have an open circle. Well, I've got a closed circle too. So a closed circle fills it up. Okay, it's a filled up dot now. It's a closed dot there at 0, 0. It's a parabola, so don't just draw a straight line. I'm up 1 over 1. But I do want to make it a little bit parabola shape, so I'm going to kind of bend that thing over. And at 1, it's a closed dot again. Show me with your arm, what does 1 look like as a graph for this last one? It's y equals 1. So if it's y equals 1, that's just a horizontal line. So from there, I'm going to draw a horizontal line at 1. It's going to look just like that. Technically, it would be an open circle at 1. But I've got a closed circle right there, so the closed circle is going to fill it up. Yes, sir.
Would that be continuous?
Yes. So this is a continuous graph. I could follow that whole line. To make it, we had to break it. We did them in parts. But I could follow that whole line using my pencil without picking it up. So yes, good question. Domain. If we're doing domain here. Thoughts. What do you think my domain is going to be? Morgan? Negative infinity to infinity. Yeah, if I get one of those, I always cheat and just write all real numbers. But yes, negative infinity to infinity. I'm just lazy. Range here. Reese, what do you think? Negative infinity to positive 2. Good. Because the bottom arrow right here goes down forever. But then it stops at 2 and it never goes higher. That ending arrow is straight out, so I'm never going up anything higher than that. Negative infinity to positive 2. Questions with that one? I'm going to graph the next one pretty quick here. Let's start with this thing. X is not 1 and X is 1. When X is not 1, we're graphing this thing. That's all of the time I am graphing that thing except when X is 1. All right, so that shape right there, it is cube root. This negative is going to flip it, so it's going to make it this shape now. Which direction is this +2 underneath the root going to be? Which way is that going to take us? It's to the right because the negative with the plus, remember, it does the opposite. So I'm going right 2. I'm going to put a dot here. The -2 takes me down 2. There's my starting dot. And it's a cube root graph, so my pattern is 1, 7. Down 1 over 1. Up 1 over 1. And then up 1 over 7. Down 1 over 7. I definitely ran out of space. But in general, my shape's going to look like that. Kind of. Because when am I graphing that? When X isn't 1. So all of the time, except when X is 1. So what does that mean? When I get to 1, I'm not doing that anymore. So there becomes a hole in my graph right there. There's just an open spot because this graph lives everywhere except exactly at that one moment in time when X is 1. So we're going to represent that with a hole. Does that kind of make sense what I'm saying there? What am I actually going to graph when X is equal to 1? 3. So up here at 3, I'm going to put a closed dot. Is this graph continuous? No, it is not continuous because you definitely have to pick up your pencil to make that hole and make the dot, or to make the dot at least. Domain? All real numbers because those arrows go left and right forever. Range? Ooh, yeah. Negative infinity to -1 because there is this one spot that you're never going to hit. It's the y value of -1. Okay, you're never going to reach that. Okay, you could, if I cheated, I would say all real numbers, y cannot equal to 1. If I wanted to write it that way, that makes more sense to me. -1, sorry. Interval notation is wonderful, but sometimes it's pointless and makes your brain hurt more than it should. Sometimes just saying everything but -1 is the best way to say it. Questions there? I know we're going a little bit quick. Wednesdays are doing us in. Let's try one. Which one? First one or second one? First one it is. Okay. We are trying to write a piecewise function. So if I'm writing a piecewise function here, how many different lines did I use here? There are definitely 3 lines on that graph. So I'm going to use 3 lines to write this thing. So 1, 2, 3. I need 3 equations. I also need 3 rules. Or like, when am I going to make this part of my graph? From when to when? So let's work with rules first. My first line, this guy right here, what x values is it going to live between? -6 and -2. So when -6 is less than x is less than -2. Which one of those lines here, Dahlia, which inequality needs to be underlined? None of them, because they're both open circles. Good. So they're both open circles, so I don't underline. Okay. My next graph, I got this guy that lives in between these 2 spots. So if it lives in between that, I'm going from -2 is less than x is less than 2. Brooke, which one of those needs to be underlined? Both of them, because they're both closed circles. And then my last one is this graph right here. That graph right there from what we got, -2 to 6. Joey, which one's underlined? The second one. The 6 is the inequality with the 6 is underlined because it's a closed circle. Now all we have to do is write equations of lines. Okay. The first one is a straight horizontal line. That one should be the easiest one. If it's a straight horizontal line, what's the y value there? 2. So the line is 2. The next one's an absolute value because you got the v. What do I need to do with that absolute value? Down 2. So it's a -2. And then the last one is a line. It's a slanted line. So we're thinking y equals mx plus b. So I need to know my slope. What's my slope going to be? 1, but it's -1. And then what would my y-intercept be if I extended that out? It'd be 6.